amplifier. So you have a breadboard and you have the dual supply here one end, and you have two voltage sources. You can see that it's a one box in which two voltage sources are there. They can be increased or decreased, and you have a multimeter to measure the output voltage. You have the op amp and the various resistors, etc. And this is the summing amplifier circuit that is shown here, same as what we just now discussed. You have R1, R2 and R2. This R3 is basically to compensate for the differences in input bias current and things like that. So right now we need not bother too much about that. So the basic idea is you have one voltage here that produces a current V1 by R1. There is another voltage V2 that produces a current V2 by R1. These two currents add here at the virtual earth point, and that flows through the feedback resistor. Therefore you get an output voltage which is the sum of the two currents, proportional to the sum of the two currents, and the currents are produced by two voltages, and therefore ultimately it becomes sum of the two voltages. So let me quickly build the current circuit. So you can see the op amp goes and sits in the proper place, and the different resistors are put in place, and the wiring is carried out. Right. So you can see the pin number 4 is connected to the negative, the blue line. The blue line is the negative of the power supply, and the red line is the positive of the power supply, that is connected to pin number 7 of the op amp, as you can see, and the black is the ground that is connected to one of the rail lines here. This is and that is also connected to the negative of the multimeter. Right. Now the pin number 2, you have one resistor, which is another resistor is connected to pin number 2 also, but they are connected to two different sources. This red line comes from one voltage source, the other red line comes from the other voltage source. They are adjacent points, but they are different, and the common ground is all connected to the same ground line. So two voltage sources are connected to the input, and this is connected to the ground. The pin number 3 is connected to the ground as it is shown here in the circuit, and this feedback resistor is here, and that is connected between as a feedback resistance between pin number 2 and pin number 6. Right. So the wiring is exactly similar to what you have seen here, and therefore now we are ready to perform the experiment. We will switch on the dual power supply, we will switch on the voltage sources, and we will also switch on the multimeter, which is also connected between the pin number 6 and the ground to measure the output voltage. Now let us start giving input voltages in millivolts. Let me increase here. This is about 100 millivolts, and this is 0, and because the gain is 10, this is the feedback resistor is 10k, the input resistors are 1k each, therefore there is a gain of 10. So 100 millivolts multiplied by 10 is 1.1, because I have not given the other input anything. Now if I give another 100 millivolt here, it has become 100 plus 100, 200 millivolts together. So this 100 millivolt and this 100 millivolt will have to be summed together at the output with a gain factor of 10. So when you do that, you get about 2.2 volts. So you can see, if I keep increasing the voltage, the output also changes to some 3 volts or 4 volts. This is 200 millivolt input, another input 200, so output is proportional to 400 millivolt. This is 10 times multiplication is there, and therefore it becomes 4 volts. Right. So the slight difference that you get in terms of an additional value here can be accounted for in terms of the tolerances of the resistors. The resistors may not be precise, and there is also what is known as an offset voltage. Every op amp can have some finite voltage at the output, even when the two inputs are connected to the same voltage or connected to the ground. This voltage we call offset. So this offset voltage, that means it is already having a residual voltage of about 400 volts, 400 millivolts, and therefore when you connect the output comes in combination with that additional offset voltage. That is why it is showing 4.4 volts and things like that. So it is a very simple configuration, one can easily do the circuit, and I have also got some data here where you can see how the different numbers come. So it is not important, maybe when we do the actual